Hello everyone. Welcome to our, I think this is our fourth, if we're counting from zero, programming session. Today we are finally going to get into robotics programming. I understand a lot of my explanations on Java concepts and such were sort of rushed, but that's perfectly fine because, rushing stuff is my specialty. Beyond that, I will be sort of going through the VS Code interface and everything else around that. So I would prefer it if you get your VS Code opened up. For those of you who have not downloaded VS Code, I would suggest checking out our Discord channel, or it's going to be in the YouTube description. I think I can pull up the link very quickly. There was a download thing. Here it is, the installation guide. Let me just copy this and put it in the chat. So for anyone who doesn't have it downloaded, I would suggest looking through that link. It will be attached to the YouTube video as well in the description. Without further ado, let's get right into loading up our interface. So I will present my window. Here we are, share. So once you open up VS Code, it will look something like this. I hope the resolution is fine. If you downloaded it using the method that I told you to download it using, which is definitely that website, then you should have everything set up. If you have not done that, then your thing will look a little bit different. Noticeably, you won't have this W in the corner. Now, this W in the corner may look relatively unimportant, but it is pretty important. So if you don't have that and you downloaded just VS Code and that's all you have experience using, then I would suggest you just head over to extensions and download the WPILib library. I think it's still on here. Yes, the official one is still on here, though you might have a few issues with a lot of it, and you might have to download Java and a few other things. But again, just follow that installation guide and you should be perfectly fine. Now, let's get right into the news. If you click this W into the corner, just raise your hand if you have a W in the corner. And I can sort of pick out the people who don't, and maybe we can get something working. Okay, Rohan, you have a W in the corner. Nice, that's a win. Raise your hand, please. Please. Makes life easier. But I mean, there are only 9 people, so you know what? It doesn't matter. Okay, yes. So Utia, who else? Yeah, just Utia. And Tanvir. Am I saying your name right? Please correct me. I have the extension though. You have the extension though or two? You just don't have the W. But you have the extension. Yes. Okay, so this is sort of the ultimate test for those of you who might not have it in the corner. If you do Control-Shift-P or Command-Shift-P, depends on your sort of laptop or interface, and you type in WPILib like this, if something pops up, then you're good to go. If nothing pops up, then you're not so good to go. So I would suggest if that doesn't work, then you might need to restart your VS Code, maybe re-download a few things, whatever you need to do. You do that. Anyways, let's get right into it. For those who do have it, click the W, and you'll notice that a little bit of an error pops up, but that's fine. And you'll notice the same thing that happened that was there before when I sort of typed it out, which is WPILib, and it'll have a few options here. So what we're going to do is we're going to create a new project, because that's exactly what we need. We need a project space, a workspace to sort of get everything sorted out. So I think I have a testing one created, but I will essentially, okay, so once you load that up, hello, Andrew, how are you doing? I should probably backtrack a little bit. Have you downloaded VS Code in the extension? Like, do you have that?
I have it.
You have it? Okay, that's good. So just click the W in the corner. You'll find it. It's like right here in the corner. And then something will pop up. It would just a little bit of a menu over here. You can scroll down, find the one that says not build a robot, where is it? Create new project. You can type it up as well, and it'll sort of give you the option with a little bit more detail. Once you do that, this screen over here will pop up. Oh, hello, Priyanshu. Please open up VS Code and let me know if you have a W in the corner. If you don't, then we can sort that out. But just let me know if you have VS Code and the W in the corner.
Which corner?
It should be in the top. What direction? Right. Top right corner, right over here, it's next to the 3 dots, this little multi-view thing. There should just be a W over here. It should, like, if you hover over it, it should say Open WPILib Command Palette, which I don't think you can see on the Google Meets thing, but whatever.
I have something I can click on, and if I hover over it, it says Open WPILib, but it doesn't have the W icon. But I have like build code robot, create a new project, and all that stuff if I click on the button.
Yeah, just do that. So you want to click on whatever the button is, and then click Create New Project. So PyLib Create New Project. It might not be in your recently used. You might have to search for it, right? So just type that out, Create a New Project. Once you do that, you'll open up this PyLib Project Creator screen. So if you guys are all on this, please raise your hand if you're on the screen. Let's just keep it at that. Please raise your hand if you're on the screen. Okay. I think that's most people. Yeah, Tanvir, just let me know how you're progressing. Again, if you don't really want to, I guess, waste your time here, the recording is going to be uploaded, so you could just check out the old YouTube recordings during this time, sort of get up to speed, and then you can watch this recording and maybe join us for the next session if you're just a little bit behind. But yeah, let's get right into it. So once you're at the screen, you'll notice that there's this button on top and a few other stuff. So we'll just click Select a Project Type, and we want this to be a template. So the reason why I'm saying we're making a template project is because this template is basically going to give us the outline of what our code is the skeleton of our code, right? So remember what I was talking about in terms of the boilerplate code? You can put down your hands now, unless you have a question. Yeah, so remember what I was talking about in terms of boilerplate code, right? So we had the public class thing before, stuff we don't really understand. You're going to have a lot more boilerplate code when you're creating code for a robot. And so we like to have our computer generate that code. So the example will generate an example code for a robot, right? So this is going to be code that already has everything set up, so you can upload it to the robot and it can drive and move around. But a template is just going to be like the bare bones, the minimum, just to get the skeleton of the robot running. Vivek, please open up your VS Code, find the W in the corner, click it, and head over to Create a New Project, and you'll get on this screen. And then head over here and click Template. Oh, wow. Let me know if you have any issues coming across that. Next, it's going to say Select a Language. So you'll see CPP, which stands for C++, and Java on the bottom. Sadly, we're going to be using Java, so just click that. And you'll see this also pop up here. So there are many different ways that we can sort of program a robot to have it move. And these are sort of the different frameworks in building a robot. So there's a timed robot. And what a timed robot does is it's based completely on the point of time, right? So it's going to be, once a certain point in time is reached, I want a certain action to take place. Or at this exact point in time, I want a certain action to take place. Or for this duration of time, I want this action to take place. So everything is really based on the constant and steady flow of time. Now, if someone pauses time, obviously your robot will be completely messed up. I mean, robots wouldn't move and pause time, but just theoretically speaking, since it's completely based on time, it's going to be a little bit different. And because everything is time-based, the programming looks very different from what we're going to be using, which is command-based. So you'll see that there's another one, which is timed skeleton, a little bit more advanced. And so this is sort of going to be even more bare bones. So it's like a very bare bones version of sort of how we can make a timed robot. Again, we're not going to be using a timed robot or anything like that, so you can rest assured. Next is a robot-based skeleton. So this is like the core, the very base of a robot. It's just going to be like what the robot needs to turn on even. And this is just going to be like the very, very basic part. So this is, I don't think any team conventionally uses this because it's really dumb. Yeah, I suggested that. You can 100% do that. That's perfectly fine. Please make sure you like and subscribe to our videos as well. That goes for the viewers who are watching this later on. So yeah, robot-based skeleton advanced. It's advanced for a reason. A lot of teams don't use this, or at least in my experience, because it's kind of dumb to write all their code from the base. But it exists, so I guess I will acknowledge it. Next, we have command robot, which is what we're going to be using, and that's sort of command style. And so I'll sort of explain how the code exactly works once we load it up, so you can sort of visually see what I'm talking about in terms of the code. But all you have to know is this is going to be based on sort of like one grand task manager person. So this is known as a scheduler. And so this scheduler is basically going to like it's going to keep track of the time, but instead of going exactly based on points of time, so 5 seconds from the start of the robot, 20 seconds from the start of the robot, and so on and so forth, it's going to just look through the commands that it has to run. It's going to be like, oh, so I have a list of commands that are going to run. Oh, so first I need to turn on the robot. Tick, I've done that. I send a worker to go do that. Oh, I need to turn this light on. Okay, sure, I'll send a worker to go do that. Once the worker comes back, they can tick it off their list. So there's one scheduler that sort of manages everything, and that's sort of what keeps a robot running. So the scheduler will only have commands and they'll take these commands to sort of process the robot and keep it moving. And that's a command-style robot and a command-style programming method that we're going to be using to make our robot function. Old command robot, this is the old sort of syntactical way that they had the command set up. We're not going to be using this, but I think that's what I used last year. So I'm a little bit unfamiliar with the newer system, but it should be fine. Next we have Romy and Romy Time Robot and Romy Command Robot. Romy is this newfangled little Raspberry Pi based robot that FRC released for team training. So we might have a few next year. Don't get your hopes up, but we might. We most probably will if we get good funding. And so this is only for those sort of Raspberry Pi based robots. And the reason it's different is because you guys weren't there for the electrical meetings, but the processor used on our robots is the Robo-Rio. And the Robo-Rio is a very expensive hunk of metal. And this is sort of our central computer, central processing unit. Makes everything function and work for a robot. And so it's very different, the Robo-Rio, from the Raspberry Pi. As such, they'll have different architectures and so on and so forth. So for that reason, there's a different sort of programming method, programming style for the Raspberry Pi based robots compared to our Robo-Rio based robots. So just click Command Robot and we should be good to go. Next, you're going to set a base folder. I think I just leave this empty. Maybe I selected the project folder. This is a lot of stuff. Okay, where is the documents folder? Robotics. And you see a lot of the old ones. So we're going to just select this folder. And that's going to be where I'm going to keep my project. So again, you can set it to wherever you keep your projects. Really depends on your, I guess, your personal organizational method. You can click that button to sort of navigate. Next, I did put this in sort of like a root folder. So this created a new folder. We'll make sure that it goes in another folder underneath it, which is beneficial to me. And I'll give it a project name. So since this is sort of our first robot, I will just call this one our first robot, right? So our first robot code, first experience with the robot, first mess up, first bug, first debugging, all that fun stuff. So this is just going to be our first robot code. And yeah, that's basically it. So once you guys are at the step, please raise your hand just to make sure that I'm not leaving anyone behind. Okay, nice. Nice. Oh, yeah, I'm tired. So much work. Whip lip. Okay, so Vivek, did you manage to get your stuff loaded up? Yeah, okay, so just raise your hand if you're good. I think most people are. Okay, you know what? I think almost everyone is good. Manjot, Vivek, hope you guys are doing good. If you have any issues, just let me know. Okay? Okay, take your time. You guys can put your hands down now. That's fine. Okay, yeah, so we set our project name. We're creating it in a new folder. Next, we're going to need our team name. So our team name, or not our team name, our team number. Sadly, it doesn't ask for our team name. Unfortunate. I mean, I guess fortunate to an extent. So team number, we are 3560, represent, lots of fun. So just enter in 3560. Again, it needs to be numbers, I'm pretty sure, so please don't enter in a string here. String is, remember, any text that is not a number. Finally, click this tick mark over here for enable desktop support. So because since we don't have a real robot, we will be using the simulation to sort of run our robot and see how it could work. And for that reason, I would really enjoy it if you just tick that enable desktop support box. Again, you can set it using, it just shows in the sort of comment under here. You can set it using the Pilot set desktop support in your project, but it's just easier to set the tick right now. So once you guys have got all of this, feel free to verify it with what you see on my screen. And once it's all the same, you can generate the project. And once you guys see this, okay, yeah, make sure you click current window because you don't want multiple VS Code windows, it'll mess stuff up. So once you guys see this sort of screen with all the stuff on the side, just let me know. If you aren't at the screen or if an error occurred, okay, feel free to close this. It's sort of useless. And you'll see this Gradle build thing on the bottom as well. So if you aren't on the screen, let me know. You'll see some errors pop up, but they're completely unrealistic and don't matter. So once you guys are at the screen, let me know. Raise your hand. If you're not at the screen and something is breaking apart, then also let me know by putting it in the chat. And I'll explain exactly what this thing on the bottom is doing once I can confirm that everyone is at sort of the same part in their code and nobody's blowing something up. Which, I mean, blowing up stuff is fun to an extent, right? Like, you guys enjoy blowing stuff up. I enjoy blowing stuff up. You know, fireworks and... Okay, build successful. That's good. So yeah, raise your hands if you see the build successful thing. Put it in the chat if you see something breaking apart, because, you know, we can sort of work that out together. Okay. Yeah, okay, Vivek, just let me know how it goes on your end. It's okay if you're a little bit behind. I just, like, hope you catch up. So any errors, feel free to let me know. I think most people are good, though, going off of what I can see. So let's get right into it in terms of explaining this Gradle thing. So if you remember from our REPL.it, 3560. Yes, we are 3560. So if you remember from our REPL.it, we used to click that little bit of a run button on the top. So it used to be in the top over here, and you just click the run button, and everything is just sort of like there's some text in the terminal, and everything works. The way that it really does work is it's building all the Java files. So remember, your Java files are sort of like a blueprint to an extent. They're just sort of like plans, and your computer actually has to go ahead and build it into computer binaries, which it can then use. And for the robot, it needs to build it to code that the robot can use, right? So the way that it builds your code, there are many different ways to do it. You can use the inbuilt Java one, which is called Java C, or you can use external build methods. This one is called Gradle, and the Gradle Builder is really handy-dandy because it can do more tasks than just build Java. It can also process new things, run network simulators, debug, and a lot of other things. So that's why we're using Gradle in our project. It's just sort of like a constructor, which turns our code into stuff that we can put inside of a robot so that it works. Utia and Andrew, do you have questions, or are those, you can put down your hands if those are just raised in terms of the not blowing up. Okay, perfect. So I'm going to put away this welcome screen because I don't need it right now. I hope that explained what the terminal did. Again, you can press any key to close the terminal. It'll probably save you more space in terms of the code and looking at stuff. So on the side over here, you'll notice your sort of environment development space. You'll see a lot of folders. So let's start from the top to the bottom just to sort of explain everything and make sure you don't delete any files. So again, please don't delete any files. You'll see this one right here, which says .gradle. This is just going to be sort of the information that Gradle uses to build the stuff. So it's sort of like a temporary folder and a few other things. Don't mess around with it. It's like there's nothing important in there, so please don't mess around with it. If you ever do need to mess around with it, there are better ways to edit the .gradle files, specifically in the settings.gradle. So please don't mess around with that. Next, we have .vs code. This will just have a few options in terms of managing our robot code and how it'll run and everything else. So just disregard it. Don't modify anything here. This is just our settings in terms of the VS Code editor itself. So don't modify it, not important. Next, we have wpylib. So wpylib also more preferences. So again, don't modify it because this is what we set up at the start of our project. If you remember, enable... oh, wow. Ow, my throat. Enable C++ IntelliSense. We're not using C++, so this is set to false. Next, we have current language. Of course, we're using Java, and we set that up at the start, so that's good. Project year. This is the 2021 season, so obviously it makes note of that, and it keeps the 2021 year over here. Team number, 3560, and remember, we did set that up at the start, so don't modify this. And again, if you do want to modify it, there are better ways to do it than to edit the wpylib preferences.json thing. So any folder that starts with a dot, not really important. Don't modify it. There are better ways to modify them that are more accessible to you. Build. So build, this is basically going to be what's the result of what your computer or what Gradle builds after processing your Java code. So don't mess around with this. There are better ways of using it, better ways than just opening the folders and looking through the classes and stuff. So don't really worry about it. It's just, this is just the result folder. So you don't need to mess around with this. It's not important. Don't open it. It'll save space if you just keep it closed. Next, we have our Gradle, another Gradle folder. This is just going to be sort of the Gradle file itself. So this is going to be exactly what Gradle uses to sort of build your code and a few other specific wrapper-based events and files that it needs. So don't modify this. Again, there are better ways to modify the Gradle files. Next, we have source or src, and this is what we're going to be using primarily. This is actually the only folder we're really going to be using besides these ones in the bottom. So I'll get into it, but you're going to go to source, and then once you open up, you'll see this main folder. We're not going to touch deploy. Deploy really isn't that important. That's only really important when we're working with co-processors and other devices on our RoboReel. Just open up the Java, and you'll notice that there's a Java folder, FRC, robot, and in here is going to be all the Java files of our code. So this is the main folder that we're going to be working in. You can open it up, but I'm not going to because I need to explain the rest of this stuff. Everyone, does this sound good so far? I'm going to drink some water, I apologize. Does that make sense, sort of? Like what you need to work with and what you don't need to work with so far? What you click and what you don't click? And why you don't click it? Sounds good. Okay, yes, okay, great. So next we have vendor deps. Vendor deps is basically vendor dependencies. So, as you know, making robots isn't really, we're not getting all our parts from one place because we aren't pathetic like Vex. There are many different places we can get our parts from. And as such, there are many different dependencies and many different like forms of code that we'll be pulling in. And because of that, we might be pulling in code from an independent company that produces, sensors, and they might have their own code or they might have their own way of processing things. And because we have this external code or code coming in from the outside or code not built by first or so on and so forth, we do want to make sure that we manage our stuff efficiently, right? And so to manage our stuff efficiently, we use vendor dependencies. So they'll sort of release some code alongside their product online. So let's say I'm buying a gyroscope sensor. They'll release some code with the gyroscope sensor along with the vendor dependency. And so this vendor dependency, I'll take it up to my code and I'll go Control-Shift-P for pylib. And I think it's dependency. Where's the vendor dependency? It's like manage vendor libraries. Here we go. And so you can actually install new libraries, and you can get new ones based on your items. So you can sort of enter in a vendor file URL and so on and so forth. And that'll sort of get you exactly what you need to download. And these are going to be the external vendor dependencies. So again, better ways to manage it. You don't really need to click on this file. It's going to be automatically edited when you open up this vendor library thing and set everything up. Okay, so let's get right into it. Or not right into it. Let me check chat. It's been blowing up. Okay. Yeah, I heard that. That's hilarious. No Vex slander. I'm not slandering anyone. I'm just saying something. It's just my personal opinion. Python is not optimized. I would have used Python this year, except it's not professionally sort of managed. And Java is, I'm not saying better, but it fits a little bit cleaner in terms of the rules. Because when you're working with Python, it's a little bit loose, and the dependencies are hard to make sense of. So I'm not saying Java is good. I'm just saying because it's officially supported, it's a little bit easier for me to teach and for me to employ new strategies with it. That's the only reason. I would use Python, though, if it was officially supported. So you'll notice there's a file called .gitignore. And .gitignore is just, if you've worked with Git before, which we are going to have to work with Git. I think I know a few of you who have, but who knows. But the point is, this is basically what .gitignore is going to do is it's basically going to list a few file extensions, right? So like .trash or .dsstore or other files that just we don't really want to use. And because of that, we just need this file in here to make sure that useless files aren't being uploaded with our Git repository. So that's the only reason this exists. Don't edit it. It's pre-generated. It's cool. It works well. And it's fine. So just don't edit it. Next, we have our build.gradle. So this is going to be all the configurations for our Gradle and how it's going to work. So you'll notice a lot of different things here, a lot of complicated stuff. And while we're not going to be using this yet or at all really, the build.gradle file is still important to know about because this is how we configure different things, right? So if we needed to change the Java version to, let's say, version 13, then we can just modify this over here. Again, don't modify it because it's pre-generated and pretty important. But if we do, then this build.gradle file is going to be generally important. This is our Gradle executable. Yes, so this is basically what's going to run on your computer and sort of manage everything. And so don't modify it. It's a shell script. It might look different on macOS as well. I don't really know. Yeah, so this is the Linux one, Gradle W, and this is the Windows one, which is gradlew.bat. And so notice that the Windows one is a lot stupider. No shade being thrown. Next, we have settings.gradle. This is probably what's going to be a little bit more important than our build.gradle. Most settings that we need to modify are going to be here. And so here we can change, the FRC year, a few other things, right? So if you really need to modify any of the Gradle settings, this is where you'd sort of do it. We're not really going to get into that in this lesson or in any lesson, but it's just important to keep note of. Finally, we have our WPILib license. This is just sort of to make sure that we don't get sued. Pretty important, so don't delete it, please. But unless you're uploading your code on the internet, it's not really all too relevant. Just make sure you keep it at the bottom. It doesn't really bother anyone. Okay, so I think we're good to go now. I think I've explained everything relatively well, and we can probably get into the code. Don't delete the license. It's, yeah, okay, so please don't delete the license. Then upload your code to it. I'm not going to be legally liable for any of that. You know what? Let's just keep it at that. Okay, so we have our deploy thing over here. Again, we're not really going to be working with this. This is if we have code processors or other files that need to be put onto the RoboRio for some reason. But if you open up this part in the robot, you'll notice that there are two folders, commands and subsystems. And beneath that, you have constants, main, robot.java, and robotcontainer.java. Okay, so let's start off with what we all think is going to be there, or what we all think is going to run, which is our main.java. Wow, this is very disappointing. I wonder why they have nothing in here. And it actually tells you in the comments, do not add any static variables, blah, blah, blah. Don't add anything. Do not modify this file, except for the parameters to start robot call. And so the reason why they're sort of saying this, and the reason why they're highlighting all of this is because this main.java file is really important. And we're only going to be using this main.java is only going to be used on the robot itself or while we're simulating. And if we modify it a lot, then it could basically break how the robot runs. So very, very important. Please don't modify the main.java file. It's cool to look into though. We have this robot base class, and then we have a start robot function, and we make a new robot. And notice a new operator here too, which is the double colons. If you guys are familiar with C++, then it'll look pretty common ground. If you're not, then it might look really strange. We're not going to be using the double colons, so don't really worry about it. Let's get right into it. So next we have our constants.java. We will actually be modifying this one. I know, really, really surprising. So why do you think we would need a constants.java file? And, oh wait, no, I should probably explain what a constants.java file does. Yes, that's important. Yeah, so all this constants file does is it keeps note of information that's going to be used that's just going to be used within the robot code, right? So we just want to make sure that these constants are easily accessible. Now, one way to think of these constants are, imagine your RoboRio to have multiple pin outs, right? Like a USB number or a pin number, and there are 10 such pin numbers. Let's say pin number 1 connects to one of our drive motors, pin number 2 connects to some gyroscope for some reason, pin number 3 connects to some LED for some other strange reason, right? So they can all go out to multiple different places. Now, to make sure we keep track of them, especially because of how our electric team could work, they could switch around the wires for multiple reasons and do all that, right? So to make sure we can accommodate for that, we will make sure that our public final class constants will only contain single variables that sort of represent constants that will be used throughout our code. So we can imagine one constant might be important, which would be the drive pins, right? So we can so these all have to be public because we want them to be accessed by everyone. And we're going to make them static. And what static means is that when they're accessed, they're going to access the object itself, not a copy of the object. So we're going to say public static, and we're going to make an int or something, let's say, and we're going to call this our left forward motor. And we'll say that this is pin number 1, right? So, or maybe left forward motor pin, right? And then you could do the same sort of thing for all the other pins that you'll need, right? So, right forward could be 2, and so on and so forth, right? And let's say that the electrical team realizes that pin number 2 is busted for some very strange reason. And maybe it might be busted because someone stepped on it or someone spilled like some water on it and it just completely died, right? And so there are multiple reasons why you might have to change the pin. So let's say it changes from, or let's say that the left forward motor pin number 1 breaks or something, and you have to change it to pin number 4. Now, if we just change it over here, if we change this to 4, then we don't have to change anything else in our code. But if you imagine it in our code, right, like if we're working with this pin multiple times, then we'll have to change the 4 every single time we come across it. But by setting it in our constants, we only have to change it in one place, and it will change it everywhere else. And again, they don't have to be just pins. It could also be something like a physics variable or something, right? So like the distance or per tick in the encoder, or it could be like the distance or the amount of time, right? So like let's say at full speed, how long does it take for us to traverse 1 meter? It probably takes 0.63 seconds or something, right? But depending on a robot. So we can call this, we can make our double, and we can say seconds time to 1 meter full speed, right? And so we can say that this is 0.63 because it's about 63 seconds. Make the constants capital, please. Again, you could make the constants capital. It really depends on your naming style, Armand. You could keep these in all caps, which some people prefer to do because it differentiates them from the rest of it, or you can just use camel case like this. So you can, it really just depends. You can make the double and you can call this time to thing, right? And you can say that this is 0.63. Now, it really doesn't matter. It really depends on what you really want to type out. If you like typing it out like this, or you like typing it out like this, I think capitalization signifies the constant, but it really doesn't matter. I personally used camel case for my constants last year because it was easier for me to type. Okay, yeah, so we're not going to be making any constants yet, but I just thought it was important to explain because we will be working in the constants.java file, which is up here. Next, we'll move on to robot.java. Now, this has the name that would seem like it fits. And you'll see that this is the VM is configured to automatically run this class, VM virtual machine. And to call the functions corresponding to each mode as described in the time robot documentation. If you change the name of this class or the package after creating this project, you must also update the build.gradle file in the project. Right. So just don't update the names of anything because then you'll have to update the build.gradle and it'll mess everything up. So please don't do that. But very simply, this is just going to take some, so this is actually pretty important. So it extends the timed robot itself, right? So while we're making a command-based robot, it's still built on that sort of timing, right? So we still have a scheduler that's based on the timing, and everything based around that, right? So it's going to extend. So the base class is our timed robot. Our robot is extending the timed robot, which is why the subclass and class thing was important yesterday. Next, we have a private, right? So we only want this to be accessed within this just to save traffic and make sure that everything is optimized. And this is going to be our command. And so this command is our autonomous command, right? So it's just going to be however we make our autonomous command, we assign it to this one, or this is going to be automatically assigned. So you don't really modify anything, or you don't modify too much within this file. Don't really worry about it. Next, we have our robot container coming in from this robot container over here. And so this is just going to be like, it contains a robot code in a simple and easy to use format so that this robot.java file can process and run it. Next, we have some important tags to learn about, which is going to be our @override tag. And so what @override does is, let's say we go back to the topics of subclasses and base classes. Let's say I have a base class. If we take our item example from last time, then let's say that the item has a function called what is it? What would be important in a vending machine? I guess that would make sense. Shine light, maybe. I don't know. Maybe like just a type of spring, right? So like spin this spring. So if you see the bottles, you'll notice that it's sort of like a spring that sort of spins, and you put your items on the inside and the spring spins and then drops out at the end. Some of them have a different system, right? Depending, like if it's a heated beverage or something, it might use a push. It might just push it out. Or it might have a crane or a different mechanism, right? So this sort of mechanism to pull the items out of the vending machine could change. So if I have a function which says spring item out of vending, or pull item out of vending machine in the .item, and that's used for spring type sort of ways to get your drink out, and then I used sort of pushing method in one of the things in my machine, then I'll have to override the code for the previous one. I'll have to change it if I want to keep the same function name. And keeping the same function name is important because that means I don't have to write multiple if statements. I can just write one sort of thing. And so for that reason, we have this at override thing. And so you put this on top of a function, any function, where you're sort of changing the code from what it used to be in the base class. Does that make sense to you guys? Does it not make sense? You're keeping the same name, but since you're changing the code, you have to let Java know that you're changing the code. You're overriding the code from the base class, right? So it's sort of like you can imagine it as if I had one painting on the bottom, right? And then let's say I'm going to paint something that's blue, or let's say it's a blue sky and I want to add clouds on the blue sky because it's just like a plain blue and I want to add clouds there for fun. Now, if I'm adding clouds, I'm going to have to take more paint and put it on top. So one way that I can do that is sort of I can erase the blue paint on the bottom, right? So just to lighten out the blue colors on the bottom, just to make sure that when I put the white on top, it doesn't have to be as opaque, right? It can be sort of like a lighter white. And because I'm erasing the stuff that's on the bottom, or because you can't see the stuff on the bottom anymore, in Java, you have to let it know. You have to say, look, I'm erasing the stuff on the bottom. So you need to make sure that you're not confusing the two because they have the same name, but I don't want you to confuse them. That's why we're using the override to say, look, I'm not using this function from the old one. I'm going to employ a newer method, and I have the code for it right here. I'm going to paint clouds over your sky, so I have to sort of erase or brush out your previous sky. Yeah, override is sort of more of a stylistic element, but I really do suggest you add that in because it's a good coding practice. And if you want a job, then I would suggest you take up the good coding practice. Okay, I apologize for that. Next, we have our robot init, right? So this is going to be in every single sort of robot function. So it's in the timed robot, it's in our current robot, it's in command robots, it's in robot skeletons, and everything, right? So this robot init is going to exist in every single one of them. That's why we're overriding it. And since we're overriding it, we're changing the code a little bit. We're basically going to say our robot container, which we specified over here, and we're going to initialize, we're going to create a new robot container object and assign it here. And so, again, it might be a little bit different, right? So in timed robot, you might have a different type of robot container. And because of that, you need to change things up. I know, thank you. I know I'm a funny person. I'm hilariously not hilarious. It's a staple of my personality. But yeah, so this is going to happen only once. That's why it's robot initialize or robot init. It's going to happen only once, and it's when we turn our robot on. So it's the first thing that happens in a robot. It's going to make a new robot container, and it's going to assign it to a robot container object over here. Okay, so that's good. And so this robot container will have all the button bindings and the autonomous and everything else. So important to have that. Next, this is our robot periodic. So you'll notice that if you read here, it's called every robot packet, no matter the mode, blah, 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 blah. So robot periodic is basically, it's going to run every single time your robot comes back to this step, right? So you can imagine it sort of like an, is violating? What is Armand violating? That's concerning. But imagine it sort of as like an infinite loop, right? Like let's say you're running laps. And at the start, you always have to wave hi to your one fan, and they're cheering you on because they like to see you suffer. Now, what that means is you're going to do all the work of actually going around the lap, right? So you're going to die, struggle, whatever you do while running a lap. And once you come back to the start, you're going to have to do one activity. And this periodic is going to happen periodically. It's going to happen whenever you tick back to the start of the lap, whenever you finish all your jobs and you come back to the start of another packet or another tick or another lap or another session or whatever, when you just come back to the start of that loop, something is going to happen. And this is that something. And that something, we can modify it. So in timed robot, it's a little bit different. It's basically going to get the current timer. Oh my God, my throat is dying. It's going to get the timer and it's going to compare the time and it's going to sort of like put in your tasks based on the current time that's received. Now, because this is a command style robot, it's a little bit different. We're going to be using our command scheduler. And so our command scheduler, remember, it's the thing that sort of manages all the commands and tasks that we have. So it's going to say command scheduler.getInstance. Now, get instance, what does that mean? That's a little bit confusing. And the get instance part is basically going to give you sort of a version of that object. And the way you can think of it is, I have a model engine, right? Like, let's say I have a model engine. We call this a V6 engine. Well, the V6 sort of model engine, I understand that exists. But getting an instance of that model is basically turning that model into a physical engine. It's getting an actual version of that I can use. So it's getting an instance, is getting a version of that model, a version of that design that I can physically play around with and use and, run and whatever, tinker with. So it's getting an instance. So it's getting a physical, or not physical, I guess it's digital, but it's getting a version that I can use, a version that I can edit, and then it's going to run it. And that's basically going to check all the current schedules that I have. It's going to pop off the first one, and it's going to do the tasks, and it's going to do that as long as it needs to while it continues to get the instance and run. And so why a V6? Oh, look, I don't really know what engine it uses. I'm just saying this for an example. So here we have a few other functions that are pretty cool, pretty important. So we have our robot periodic. This will run every time our robot comes back to that loop. And this is regardless of what mode our robot is in. Before I get into explaining the modes before I get into explaining like the other modes, I should probably explain like what it means. So a robot sort of has 4, I think, well, 3 in real life, but 4 in our code. We have about 4 different modes for a robot. One is disabled, where a robot is powered on, but nothing is supposed to be working, right? And so this is the sort of phase where everything should be turned off, everything should be not working, and a robot should just be idling, right? So this is sort of the idle phase. Then we have autonomous. So this is when a robot is automated by the code. So it's running based on whatever code is put on there, and our controller will have no effect on what's happening. That's the automated mode. And we have teleoperated, which is it's dependent on what our controller is doing and what we do with our controller, right? So we can drive it around with our controller, we can press buttons. Human interaction is involved in some way. And finally, we have simulation. This is test periodic. Well, test or simulation, I think. They might have changed the name. This is going to happen once in sort of a simulated mode. And that's how that's going to function. How long is the auton period? 15 seconds or something, right? Correct me if I'm wrong. It's 15, right? Or is it might be longer. I don't know. FTC is 30, I forget. It's like, I think it's 15, 30, something like that. I don't even know. It's a very short amount of time, but you score double points in this. So you want your robot to go zoom, zoom. And that's sort of like the basis of it, right? So you'll notice that for each of them, or each of the 4 modes in the simulation, disabled, and everything else, you'll have an init and a periodic. And I explain what that means. Init happens only when you first start that mode. So if I switch from disabled to teleop, when I first do that, there's going to be something that happens, and that's going to be the teleop init. And then while teleop is running, or while the mode is running, every time it sort of comes back to that lap, it'll run the periodic function. And at the base of all that is your robot periodic. So robot periodic will always run, but these are just external sort of different periodic methods. So you can imagine it as sort of a lap within a lap. So sort of your robot is always running a lap, but then when you're in teleop mode, your robot's always running a lap, and now your teleop is always running a lap. So there are 2 different laps and 2 different racers, but it's still a part of the same robot. Which is a little bit confusing, I understand, but that's just sort of how it works. And so we'll just look into the code a little bit. So we see a disabled init and a disabled periodic. Obviously, there's no code inside of them because we want the robot to be doing nothing. So I think doing nothing is pretty important. Next, we have autonomous init, where this is basically going to do, when we first start our autonomous mode, we want it to do something. And this is that something. So it'll create our new autonomous command. And it'll get that autonomous command from our robot container, .get autonomous command. So it'll get our autonomous command, or whatever command we'll have in our autonomous function, and if it isn't null, and null means like nothing. So if it actually exists, if it isn't null, then we want to schedule it. We want to put it into our command scheduler so that it gets put into there, and it can be run next. So we put it into the list so that it gets run at some point, right? So that sort of happens. Next, we have our autonomous periodic. Since our command is put into there, we don't really have to do anything because our robot periodic will do it anyways, since it's instancing and running whatever command is put in there. Next, we have teleop init. And so when we're starting teleop, or the mode with our remote control, we want, if our autonomous command isn't equal to null, so if it actually exists, then we want it to cancel. We want to take it out of our command scheduler. We wanted to get it out of there so that we can run whatever teleop command is, right? And then we have our teleop periodic here, and our test init, we're just going to cancel them all for some weird reason. I don't even know, man. That's why it's test. It's completely useless. But the point is, these three matter, and what you do in each of the phases also matters to an extent. So that's our robot.java file. We only have about 8 minutes, so I'm going to very quickly run through our robot container. Sadly, we have no code written today. Tomorrow, we're going to get, or not tomorrow, in our next session, we're going to get our robots, robot motors and everything set up, and our simulator set up so we can sort of move our robot around and see how that works. Or maybe we just do a console command. I don't know. We'll see how it goes. It depends on my mood for the day. Let's get right into it. So here we are going to take our subsystems and our commands, which I haven't gone through yet, but they're sort of the basis of our robot. We're going to generate them. We're going to configure our button bindings. And so that's this function over here. And we sort of, we can, in our controller, we can say the A button will run this command and so on and so forth, right? So this is where we sort of configure our button bindings, and that's very important. And this is that function we saw before, which is our get autonomous command. And so that was a very brief run through, and I realized that didn't even take a minute. So I'll actually go into it in detail. Maybe I shouldn't, actually. Maybe I shouldn't. So do you guys want me to go over the commands and subsystems part, or do you want me to go into detail on what configured button bindings means and all this stuff? I think button bindings is going to be more important, actually. Config button. Okay, yeah, so you'll notice that when we first run our robot container, we're going to configure our button bindings. That's the one thing that happens when you create a new robot container. So for the constructor, or the formula to create a new robot container, remember that's what this is, when you have no return type except for the function name itself, we're going to just run this configure button bindings function. And so in this configure button bindings function, it's important because this is how our teleop is going to function. This is how our teleop is going to determine how we move it around. So what we wanted to do is sort of, it says like link Xbox controller. So you can imagine an Xbox controller sort of overlaid on top of it. And what you can think is, if I press the button A, I want a certain command to run. That's what a command-based robot means. Instead of scheduling it based on time, where it's sort of like, oh, at 20 seconds, I want this to happen. Or regardless of the time, if the controller is pressed and if this certain button is pressed, I want this to happen and it takes this amount of time, like a timed robot would. A command robot is basically just going to go like, oh, so you press an A button. Well, I'm going to add this to my command scheduler. And once it gets to that point, I'm going to run that command. So basically, all the button does is it adds a command to that command scheduler. And so we can set it so, oh, the Y button will add our shoot command. The right trigger will add our move forward because we're using some weird controls. And using our A button will turn on our intake. Using our B button will turn on our laser death cannon, right? And so on and so forth. So each button will be bound to a certain command. And this command is basically is the basis of our robot. It's how our robot moves. And so that's all the configure button bindings is. It's just saying, for this one button, I want this command to run. And that's how our entire teleop is going to be built. So here we have our autonomous and teleop all really interfaced into our robot container. Considering I have 5 minutes left, I will very, very briefly explain subsystems and commands. So you can imagine subsystems sort of as a limb or on your body or just as a mechanism, right? So in a robot, you can imagine it as the intake subsystem or the lift subsystem or the shooter subsystem or the drive subsystem or so on and so forth, right? So it's a subsystem of the robot. It performs only one general function, or it can perform many different functions, but it's built up of some certain components, right? So let's say, for example, if you have our shoot subsystem, well, yeah, we can, in our shoot subsystem, or in the code for a shoot subsystem, I'll open up the example one over here, we sort of initialize what it uses. So we can initialize the motors here, we can initialize any sensors that it uses, we can initialize all of that. And then here we can sort of get in our periodic functions if we need them. And remember, this will be called a once per scheduler run. So after we run that lap around, once we come to that tick, it's going to run our periodic, and that's what that means. But we can sort of set up our motors in different parts of our subsystem, and this is just going to set up, oh, so this subsystem exists within our robot. These are the motors and the sensors that are part of this subsystem. And now that I have that all set up, I'm going to take the subsystem and I'm going to give it a few commands. And what these commands will do is they'll basically take the elements of the subsystem. So let's say in our shooter, we have 2 motors, for flywheels, right? So to shoot the ball out, we have two motors to sort of move that. Well, I've initialized the two motors. Now I'm going to make a command, and I will call it shoot command. And the shoot command will basically turn those two motors on, right? So you'll notice over here, we have a little bit more code. So you don't really need the suppress warnings thing. That's just not really important. But we need to bring in our subsystem, right? So our subsystem should be imported into here. And when we're formulating it, or when we have this formula, we want our subsystem to be a parameter. So we need the subsystem, or we need some subsystems for this command to work. Again, you can have multiple subsystems per command. You can have hit and run, move the robot and shoot the ball. Multiple subsystems working together, right? So you'd have to add two parameters in that situation. But you add all the subsystems you need for each command, or for each respective command, into the parameter section over here. Then you initialize them, so you make it however you need to make it, and then you add the requirements. So you say, look, this command needs this one thing. So make sure you add this add requirements function over here. Next, we have an initialize thing. So this is going to, when you first put it into the scheduler, this is going to happen. So let's say that this is a shoot function. Well, when we first put it in, we want to make sure that the balls are in position. So if we have a little bit of like a touch sensor or something, we want to make it so that when it touches this point, it's going to send a signal out, and it's going to say okay, or it's going to say bad. This is what happens when we first do it. Then we have execute. So every time the scheduler runs while the command is scheduled, right? So let's say that this command will take a decently long amount of time. It's going to shoot the ball, and then it's going to reorient the shooter or something, right? So it takes a while because you're going to have a lot of parts to move. Well, it's still going to be put back into that lap for as long as it's put in there, right? So there's going to be another lap on the side, another little person running, and every time they reach a certain tick, this execute thing will happen, right? So that's sort of our periodic version of our command. And once the command ends or is interrupted in some way, right? So maybe we're shooting and maybe we need to stop shooting, so the person lets go of the button or they cancel it somehow, then we're going to run our end function. And we have a Boolean parameter here, which is interrupted. So if it is interrupted, and that might be an error. Then if it's an error, we want to log that error, or we want to let the user know that this is an error and do that, right? So this is going to be what happens all the way at the end. So there are three phases to it, which is the start, execute, which happens constantly, and the end. So start and end only happen once, execute happens constantly while the command runs. And is finished, it's a really stupid function in my opinion, but it returns true when the command should end, right? So if there's some sort of an indicator, which is to, maybe it needs to stop. Maybe it's like a scan function, which scans the area around it using sensors. Maybe it should stop after 2 seconds, right? So you can sort of implement that into your is finished. And that's just a general brief overview as to the code and the different aspects of our robot. If you have any questions, please say them now because we have about a minute left. I hope that was fun. We'll get to actually programming it tomorrow. More of a theoretical class, this one, but I hope that was fun. If you have no questions, you are free to leave the meeting. Not tomorrow. We will have one next Thursday. You don't really have one.
I sincerely dislike command-based robots. But
really? Why?
I don't like it. Maybe I'm not used to it.
Armand, you'd hate asynchronous programming. Because this is essentially asynchronous programming.
No, I mean, I'm okay with asynchronous, but then just make functions. What's that?
This is basically just making functions.
Andrew, stop. You're so annoying. Oh my goodness. That's a major Andrew.
What did Andrew do?
He called me.
On Discord?
Yes, just to have it come through this call.
Oh,
you know what you did, Andrew? Stop being quiet over there. Anyway, yeah, I don't like command-based robots. Probably because it's just new. I'm probably used to the old stuff. I guess that might be one reason. I'm gonna block him right now. That's what's gonna happen.
Okay then. Yeah, you guys can feel free to leave. I'm gonna stop the recording now as well. So I think it's